Check this out. What? Why did that happen? Let's try it again. Ah, putting the red light in turns off the other colored lights. That is some shenanigans. What is going on? Well, my dear friends, welcome to part 2 of Circuits for Beginners. In this episode, we will learn about how electricity is lazy and why adding a red light to this circuit turns off the two white and the blue lights. Whereas if we were to add another, nope, that's a red light. Hold on. If we were to add another blue light, what? See? Hey, it still works. Okay, so there's something finicky or there's something shenanigansy happening when we add the red light in particular. Okay, so we have a hypothesis that the color of the light has something to do with the fact that the other colors turn off. How could we test our hypothesis? Well, let's try a different color light. Maybe we try green. Let's try green. Okay, that's very interesting. If I pull out the green, it might be a little hard to see on camera, but the green light is causing the other lights to dim, but not necessarily turn off. Okay, so green makes it dim. What is this light color? This is white. Okay, white doesn't really have much. Well, it causes them to dim a bit, but not as much as the green. Interesting. We also have a yellow light. Let's try this, and I'll try to make my fingers. Oh, look at that! Oh, exciting. Okay, so to update our hypothesis, when we add, well, I should say, to update our observations, when we add a white light to our two white lights and our two blue lights, no significant dimming, just like a little bit of dimming. When we add a green light, I would say it's a significant amount of dimming. When we add a yellow or red light to the same circuit, all four of these lights turn off. And if we wanted to do a real experiment, it would be better if we didn't have two blue and two white. But I think that it's interesting to see how the two white and two blue don't affect each other as much as the green, and in particular, the red and the yellow. Okay, so what is happening? It has to do with the electromagnetic spectrum. So the electromagnetic spectrum is a fancy word for light. The colors that we see in this world are a tiny slice of the full spectrum of light, and that is called the visible light spectrum, because humans like to label things based on our own experience. It makes a lot of sense. But it is a tiny slice. And if you look at the picture of the electromagnetic spectrum, on the low energy side, you have radio waves. And on the high energy side, you have gamma rays. If we're going to go up in order of lowest energy to highest energy, you go from radio waves to, I hope I get this right, to microwaves, to infrared, to visible. And after visible, you get ultraviolet and X-rays, and then gamma rays. I'm pretty sure that's right. I used to know this like the back of my hand, and now I work on other things, but I still love this stuff. So, on the low energy side, we have infrared, and then you have visible, and then on the higher side of the visible, you have ultraviolet. So, red light is the lowest energy of the visible light that we can see, whereas blue and white, which is more kind of like a combination of all the colors, is going to be closer to that ultraviolet side. So that has higher energy. Okay, but that's kind of funky, right? Because you would think that adding something that's lower energy would mean it would be brighter. Well, the sneaky thing with electricity is that it is very lazy, which I can relate to. Electricity is so lazy that if you give it an easier path to take, it will take that path and it will skip all the other paths. So I'm simplifying a bit here, but what is happening with the red and yellow lights is that it is way less energy for the electricity in the battery, the energy contained in the charges in the battery, to flow through the red light than it is to flow through all the other lights. So they're it's kind of just skipping the other ones because it's like, nah, no thanks, I'm good. Pretty wild, right? I love that. This is one of my favorite phenomenon to explore when I teach electronics and circuits. I will leave you with a question. There are two ways to build circuits. This is just one way. It's a little tricky to see on the breadboard, but this is a parallel circuit where the components are connected in loops or head to head. So basically, like this, you're creating a bunch of tiny, tiny circuits, a bunch of mini circuits connected to one power source. There is a second way to connect electronic components in circuits. I wonder if you can think about and or explore what that other way might be. And then as a part 2 of that question, what do you think would happen if we tried this same experiment in that other circuit configuration? So right now we've done a little experiment in a parallel circuit configuration. What would it look like in the other circuit? And how might we test this same hypothesis or how might we evaluate the same question? So excited to hear what you think, my dear friends. And thank you for joining me as we learn about the wild and weird, delightful things about electricity. So cool. This universe is just so magical, and I love sharing my enthusiasm for this stuff with you and just reminding myself and all of you with me how incredible it is that we get to partake in this universe, that we get to probe its phenomenon and better understand how freaking cool everything really is. So, thank you for joining me, and we'll see you next time.